Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in JNCIS. In this lesson, we'll be covering VLANs. Now, you may say that we've already covered VLANs. Yes, but we haven't covered VLANs from the provider's perspective. In this lesson, we'll be going over provider bridging, otherwise known as 802.1 AD VLAN tag stacking. Just like how 802.1Q VLAN tagging was revolutionary for logically separating traffic traversing the same physical network, QinQ provider bridging is very similar in that it can logically separate tagged traffic. VLAN tagging allows for 4,096 possible tags, which is rather restricting for a service provider. Being limited to only 4,094 possible logical broadcast domains is unlikely to be sufficient. However, QinQ tagging allows for nearly 16 million possible tag combinations. With this many, several broadcast domains could be allocated to each subscriber with minimal risk of reaching capacity. Now, before we move on with reviewing the technical details and frame processing flow of provider bridging, let's go through a few brief refreshers of 802.1Q tagging and its limitations. So, I mentioned that VLANs allow for logical separation of traffic. Specifically, VLANs allow us to configure multiple broadcast domains on a single physical switch, and control which ports are a member of which VLAN. Ports which are not a member of the same VLAN would not receive a broadcast frame. VLAN tagging is done using a frame header field which is defined in IEEE 802.1Q standard. Every transmitted frame across a tagged link will have this header set to the VLAN ID the frame is a member of. Recall, though, that ports may be configured as trunk ports or access ports, where access ports transmit untagged traffic. Trunk ports transmit and receive tagged traffic. This packet diagram, here, contains an 802.1Q header in the third row, here. The VLAN ID, or tag field, is 12 bits in length, limiting the tag ID to 4,096 unique values. As I mentioned earlier, this is likely to pose a problem to service providers. This could even pose problems to a large enterprise, where each division or department might have many different security zones and broadcast domains, which must be separated from one another, potentially exceeding this limit. Step onto the stage, IEEE 802.1 AD. As we see in our diagram here, we have the provider's network in the middle. The provider's network interconnects two customer sites, shown on either side. The customer subscribes to an L2 VPN service from the provider. This means the two customer sites are interconnected at layer 2. As far as the customer is concerned, the provider acts like just another network switch. However, the two customer sites could be very far away from one another, across town, or even across the country or world. The transport protocol that the provider uses to segregate the customer traffic from one another is 802.1 AD QinQ tagging. The provider does this because the provider did not want to limit their L2 VPN customers to only using a single VLAN ID, and yet still needed to support at least 3,000 customers in this Layer 2 environment. This is accomplished by assigning each L2 VPN a range of CVIDs, or customer VLAN IDs, and an SVID, or service provider VLAN ID. The customer will configure their interface connecting to the provider equipment as a trunk that is a member of the range of assigned VLANs, the CVIDs. In this case, we'll follow a frame that is assigned the CVID of 35. The customer will send the 802.1q tagged frame to the provider, and when the provider receives it, CVID35 on this interface is then associated with the customer's L2 VPN, and a Ethernet switching table lookup is performed on the destination MAC address to determine the port to forward the frame out of. And an SVID is stacked onto the frame header, outside the CVID header. In this case, the SVID is 74. Within the provider network, the frame is switched just like any other Layer 2 environment, following the loop-free topology for this VLAN 74 broadcast domain towards the destination MAC address. Just like in any other Layer 2 switching environment, if the destination MAC address is not known, the flooding mechanism is used to ensure the frame reaches its destination. When the frame reaches a destination, the provider switch will strip off the SVID header and transmit the frame towards the customer equipment, with only the CVID header and other frame contents unchanged. And that's how provider bridging works. I appreciate you working through this lesson with me on provider bridging. I hope that this lesson has been informative for you, and I would like to thank you for viewing.